All right, today we're solving a tech mystery that has been driving developers crazy for years. It's a classic case of super slow performance, a story of two different operating systems, and a culprit that, well, might not be who you think it is.
So it all kicks off with this really common complaint, which this Hacker News user just nails perfectly. You're doing something that involves a ton of small files, like, say, compiling a big piece of software, and it just feels painfully, horribly slow on Windows. But then you run it on Linux on the very same machine, and it flies. And we're not talking a few seconds difference here. We're talking about something taking 30 seconds on one OS and a whopping 10 minutes on the other. That is not fun.
So when you see a performance gap that massive, what's the first thing you point your finger at? The file system, right? The prime suspect is almost always NTFS, the new technology file system that's been the backbone of Windows forever. But is it really the bad guy here? Is it just bad at these kinds of jobs? Let's dig in and find out.
Okay, first things first. We need to properly introduce the main players in this mystery.
In one corner, we've got NTFS. You can think of it as the Swiss Army knife of file systems. It was built for the Windows world, so it's packed with features for security, permissions, you name it. And in the other corner, we have ext4, the absolute workhorse of the Linux world. It evolved over time with a laser focus on being fast, efficient, and super reliable.
But here's the thing. A file system doesn't just exist in a vacuum. Nope. It's actually built on top of an even more basic layer, the partition style.
The easiest way to think about this is like building a house. The partition style, that's your foundation. It sets out the basic structure. The file system is everything you build on top of that. The rooms, the walls, all of it.
For decades, the standard was this thing called MBR, the master boot record. But it's got some pretty serious limitations for today's world, like you can't have a disk bigger than 2 terabytes. The modern standard is GPT, or GUID partition table, and it's just worlds better. It can handle massive drives, way more partitions, and it even has built-in checks to make sure your data doesn't get corrupted. Pretty much any new computer you get, Windows or Linux, is going to be using GPT.
Okay, foundation is set. Let's get to the main event, that clash of philosophies between NTFS and ext4.
So the entire design philosophy behind NTFS is to be this super robust toolkit for Windows. It was created for a world that needed complex permissions and serious enterprise-grade security.
And you can totally see this philosophy in its features. You've got access control lists for incredibly specific user permissions, encryption built right in, journaling to keep things from breaking after a crash. It's just a powerhouse of functionality. ext4 hat, on the other hand, is coming from a completely different direction. Its design is just relentlessly focused on pure performance and efficiency, especially for the exact kind of developer work we're talking about.
Now, this is where it gets really interesting, because these features are practically a direct answer to our mystery. You've got extents, which helps group small files together so they don't get scattered all over the disk. And delayed allocation, which basically waits until the last second to write data so it can make a smarter choice about where to put it. These are optimizations that are tailor-made for handling thousands and thousands of little files.
So on the surface, it seems kind of simple, right? NTFS is for features, ext4 is for speed. Case closed. But hang on. A 10-minute compile time? That's insane. The difference between the two shouldn't cause a bottleneck that bad. So what is really going on here? And right here, this is the plot twist in our whole mystery. The true culprit isn't really the file system itself. As people who've dug into this have found, the real performance killer is something else entirely. These things called file system filter drivers. So what the heck is a file system filter driver? Just think of it like a security checkpoint. On Windows, programs like your antivirus software, and yeah, that includes the built-in Windows Defender, they install these drivers. They sit right between your apps and NTFS, and their job is to stop and inspect every single request to open a file, read a file, or write a file.
Okay, so here's the critical problem. By default, that scanning process is synchronous. That means your app, say your code compiler, makes a request, and then it's forced to just stop and wait. It can't do anything. It's just sitting there until the filter driver finishes its scan and says, okay, you can go now. Now imagine that little pause happening not once, but 10,000, 50,000, maybe 100,000 times for every single file in your project. Each one of those tiny pauses adds up, and pretty soon you've got a massive, soul-crushing bottleneck.
So let's bring it all home. What's the real takeaway from this whole mystery? Let's get to the final verdict.
So here's the crucial point. NTFS itself isn't inherently horrible. Yeah, ext4 might be better for some jobs, but that crazy slowdown that developers see on Windows, it comes from the interaction between the file system and all those layers of security software running on top of it. It's an ecosystem problem.
And hey, you don't have to just take my word for it. Microsoft themselves have basically admitted this is an issue. That's why they created dev drives. And the real magic of a dev drive isn't just that it uses a newer file system. The most important part is that it tells Windows Defender to switch into a special performance mode. And what does that mode do? It scans things asynchronously. That means it doesn't force your app to stop and wait, which completely solves the bottleneck we just talked about.
This whole case is a perfect example of how complex modern operating systems are. Performance isn't just about one thing anymore. It's a story told in layers, from the partition style to the file system, all the way up to the security software. And as we just saw, the most obvious suspect isn't always the one to blame. The real answer is often hidden in how all those complex layers work, or, in this case, don't work together.